Optimization of the process of producing electroerosive charge of tungsten-free hard alloy. Introduction. Currently, sintered carbide alloys are widely used in various industries, in particular in the production of construction machinery and equipment. However, the problem of saving such an expensive material as tungsten is acute. In order to save scarce tungsten, tungsten-free hard alloys based on carbides, as well as carbonanitrides of transition metals, primarily titanium, have been developed. The relevance of recycling this alloy is associated with the presence of expensive components in its composition, such as titanium, nickel and molybdenum. One of the most promising and not industrially used methods for grinding any conductive material, regardless of its hardness and other properties, is the method of electrical discharge dispersion. For a charge, one of the main technological properties is optimal dispersion. Therefore, optimization of the process of obtaining a charge for the production of tungsten-free hard alloys was carried out based on the average particle size by conducting a full factorial experiment. The optimization problem comes down to the experimental determination of such a combination of factor levels at which the maximum-minimum value of the output parameter is achieved. To do this, use the Box and Wilson steep ascent method. Materials and methods. To carry out the planned research, tungsten-free hard alloy waste was selected. The oxygen-containing working fluid, distilled water and the carbon-containing working fluid, ethyl alcohol, were chosen as the working fluid. For waste dispersion, an installation protected by RF patent No. 2449, 859 was used. The operating parameters of the electrical discharge dispersion installation were selected as factors: voltage on the electrodes, capacity of the discharge capacitors, and pulse repetition rate. The optimal operating parameters of the installation were determined for a distilled water environment. To assess the influence of these factors and mathematically describe the process of producing electroerosive particles, a first-order model of the form, an experiment planning matrix, was compiled. Figure 1 and levels and variation intervals were selected. Table. After calculating all coefficients, Equation 1 takes the form water and alcohol, respectively, as a result of checking the statistical significance of the coefficients. All coefficients of the equation modeling a full factorial experiment in distilled water and ethyl alcohol turned out to be statistically significant. The resulting equations were used to climb the response surface steeply. The steep ascent began from the 0-point main levels. x1 equals 150 volts, x2 equals 150 Hz, x3 equals 45.5 microfarad. Tables to end. The study of the granulometric composition of electrically eroded charged particles was carried out using a laser particle size analyzer analyset 22 nanotech. Figure 2. The following presents the results of experimental studies of the composition, structure and properties of tungsten-free hard alloy particles dispersed by electroerosion in distilled water and ethyl alcohol, obtained under optimal operating conditions of the installation. Results and discussion. The results of studying the granulometric composition of tungsten-free hard alloy particles obtained by electroerosion in distilled water and ethyl alcohol under optimal conditions are presented in Figure 3. It has been experimentally established that particles obtained from TFHA waste have a particle size from 0.372 micrometers to 65.6 micrometers. It is noted that the particle size distribution of particles is significantly influenced by the properties of the working fluid. It has been shown that the average particle size obtained in ethyl alcohol is 1.2 times larger than the average particle size obtained in distilled water and is 51.94 micrometers and 41.63 micrometers, respectively. Conclusion. 1. The optimal operating parameters of the electrical discharge dispersion installation were determined by setting up a full factorial experiment on the average particle size of the resulting electroerosive materials. 2. According to a series of experiments, the limiting value of the optimization parameter Y was accepted, which was 41.62 micrometers and 51.94 micrometers for distilled water and ethyl alcohol, respectively. Thus, the optimal parameters for the process of producing electroerosive material are: capacity of discharge capacitors 65.5 microfarad, voltage at the electrodes 200 volt, pulse repetition frequency 200 Hz. 3. It has been experimentally established that particles obtained from BVTS waste have a particle size from 0.372 microns to 65.6 microns. It is noted that the particle size distribution of particles is significantly influenced by the properties of the working fluid. It has been shown that the average particle size obtained in ethyl alcohol is 1.2 times larger than the average particle size obtained in distilled water and is 51.94 micrometers and 41.63 micrometers, respectively. Acknowledgements. The study was supported by the Russian Science Foundation Grant 24-29-03-16. Thank you for your attention.